Hi, I'm Nicholas,
I'm Jacob.
and this is our final presentation on alternative haptics for the purpose of better accessibility. Page down. Our project is about prototyping an add-on to an existing game controller. Alternatively, we had the option to create a brand new controller, but we ended up choosing prototyping an add-on. It focuses on diversifying haptics as current modern haptics are too harsh for those with sensitive hands or any form of disability that makes it so that vibrations like that are painful. Um, as well as it will give directional cues that could normally be conveyed through audiovisual means. And this means that the controller could be put in the hands of someone blind, and they would be able to know where to go in game using our project, using our using this controller add-on. Um, Page down. What we'll be covering our the problem that we're trying to solve, how important this problem is, like why it's important, our justification, what we were trying to do when we solved this, and why we did it. Other examples of alternate haptics that people have done in the past, or how it is currently going. Um, our methods of gathering research and testing, our development process, and that one's 3 slides. And then we'll be showing you a live demo, which we've recorded, but it's still live. Um, uh, our user testing results, and then obviously our conclusion. But on to the presentation. So currently, our issue is that current haptics feedback is set at a level that is too intense, and it's not designed for the average user. This causes issues. This can cause pain to people with disabilities. This can cause um, all sorts of things. This can even cause pain to people that to average users, and it has. Um, as well as these haptics are blunt, and they aren't as specific as they can be. Um, they can rattle the users in a way that is simply isn't worth the benefit that they offer. But what if you could create something better? So what's our problem? Why is this important? Accessibility is an issue that affects this generation of gamers more than ever. And the reason for that is because it's never been easier to develop for these disabled individuals. Um, as such, we strongly feel that that this addition could greatly benefit those people, as well as provide a better form of haptics that is more precise and, in general, able to do more. Providing a tactile interface in the way that we are going to be that we've done um, uh, would mitigate this pain and discomfort that players who are sensitive to it uh, already feel, as well as allow us to create a physical sense of direction that could then be used for our blind players. Um, and I'll let Jacob talk about our goal.
So, of course, given that problem, our goal is to solve it. We want to develop an alternative to these traditional haptics that, instead of using rumble, uses a tactile interface, something you can feel on the controller, because it's much less harsh and it's much less invasive. It's up to the user to feel that difference. We also think that it's a good idea to allow for directional inputs to be felt with this, because that would allow for more options for developers when creating their games to convey this information to their users. Currently, We found a bunch of other solutions, but these are two the noteworthy ones because they sort of align with the projects that we designed in our design thinking process. On the left, you can see a haptic controller grip, and this uses an actuator to push a plastic pad outwards onto the player's palm as the game designer intends. So if they want to, I don't know, simulate trash compactor walls coming in on the Death Star, they can squeeze those out to make the player get that feeling of compression in their hand. On the right hand side, we can see a cross section from a sorry, not, I'm thinking ahead, a haptic glove that uses these little metal pads at the fingertips. The design idea behind this is that softer surfaces envelop the finger when you press them. For example, a plush animal, if you were to press into it, the surface would depress and wrap around your finger. Whereas if you were to press onto a sheet of glass, it wouldn't flex much and you wouldn't feel it around your finger. So the glove is designed to dynamically change the shape of the piece that's touching your fingertip to envelop more or less of your finger to feel like you're touching a softer or harder surface. So since we're in a global pandemic, we couldn't actually make any kind of prototype as we don't have access to 3D printing or Arduinos, and we didn't really have any way to get these prototypes out to people. So we had to do some uh, bending around these restrictions. We used remote testing, where our partners who were tested were given a description of what the device is and what it's meant to do, as opposed to being able to work with a physical prototype, and we're meant to imagine how to use it when they were filling out our NASA task load index and SUS surveys. We had Mozilla Hub's room where we had our meetings and things like this. And this kind of remote communication allowed for the project to go forward in the way it was intended while still maintaining a safe distance to prevent spread of the coronavirus.
Our initial development ideas were Spradley.
Oh, sorry, mine's first. The Electroactive Haptic Plastic Tactile Haptic, which is a series of pads underneath the user's fingers on the controller grip. Electroactive plastic is a type of plastic that can harden when a current is run through it. And so, by having these pads under the fingertips, the designer can harden or soften these pads at will, allowing the users to squeeze those pads whenever they think they need to feel it and tell the difference between a squishy pad and a hard pad to get that tactile information. It's uninvasive and it's up to the user to feel that it's not forced upon them like Rumble. The other solution is Nick's
Metal
explanation.
plate tactile haptics. And the way that this worked was we were going to create a brand new controller. Initially, we thought this was a good idea. Basically, what would happen is these plates would push out with little force, and it would actually physically deform the controller based on based on a variety of different things happening in game, and they would do the exact same thing as the electroactive plastics, but instead would not be an add-on and would be a mechanical solution of a brand new controller. We decided against this because the metal plates had uh, a very it was something that when shown to potential users, they were very worried about getting pinched. They were very worried about getting hurt. It wasn't very appealing as a design, and that's completely understandable. But the electroactive plastics, on the other hand, were they're very squishy to the touch initially, like they're soft, and then when you harden them, they become hard, and it's just a very uh, pleasant way of doing what we were trying to do. And thus, in the end, we went with electroactive plastics tactile haptics. It's a mouthful.
So the design we settled on looks like these two pictures we have here. It is consisting of three main components: a plastic microcontroller housing that gets attached to the controller's body and houses the electronic components, as well as these pads that contain three electroactive haptic pads that are Velcro attached to your controller. The reason we split it into three individual parts, the one main housing and two of these pads, is so that you can reattach it to any controller. Um, by only having to remake or repurchase this central clip-on piece, and using Velcro for the part that goes on the grips, the grip pieces, the most expensive pieces, can be reused on any controller since Velcro doesn't need a necessary shape. Um, Instead of making one that's the exact shape of, let's say, a PS4 controller's grip, you can't use that on an Xbox One controller. Looking at the inside, the electronics are fairly simple. In this picture we have here, there are LEDs as stand-in objects for where the electroactive pads would go, since they are very similar in use. You power the electroactive haptic pads, and they harden. You power the LED, and it turns on. The Arduino is being used to control the which pads are being turned on and off, and it's receiving input from the computer in the form of a direction, since we want our pads to be able to simulate direction to the user. If you give it forward, it'll turn on the top two pads. If you give it right, it'll turn on the right three pads, etc., similar to that, based on the angle that you give it.
Now for a demo of our project in action. We actually have a video that is open right here. I actually do not believe this is loud enough, but there is audio here, and we will link the video. But basically, the gist of this demo is that we are showing off the Electroactive Haptics. We don't have a physical version of them, obviously, due to the pandemic. But the idea is that it gives direction, and eventually, using this direction, if you see me going back and forth, you'll see these reds. You see how this means left. Oh, this means it's right on top of me. There it is. Um, and yeah, that's the whole point of this demo. It's just we're hunting buried gemstones, basically buried diamonds. And that is our demo. Uh, these are our sus results and our TLX results. As for our sus results, we received a relatively a good score um, of 68 or of 72. Sorry, the average sus score for a product is 68. This means that our score was above average in that regard, meaning that users found it easier to use. As for our TLX results, our average was 38.4 on average, which is actually really good. As the lower your score with TLX, the better your product. And as long as it's below a certain amount, I believe it's around 60 something. As long as it's below, that means it is a very usable product. It is not a very hard to use product. And that's really all. There's more about it in the paper. Overall, this project is basically completed, but due to physical restrictions, we were unable to create a physical replica of our project. Even without all that, all the different projects that we completed that were related to our main project helped us better visualize it more and more, and we believe that now we finally have a solidified view of what this project is. All that's left is to print it and set up the Arduino to function with it. Thank you for listening. Have a great
Thank
day.
you.